Hey everyone, and welcome to lesson 3.11. Today we're going to be factoring perfect square trinomials. So just another kind of special quadratic that we've been looking at in this unit. Now a perfect square trinomial, so for example this x plus 5 squared, we can expand that in one of two ways. Now the first way is if you take your x plus 5 and write it out twice and expand it, you should end up with x squared plus 10x plus 25. Now, when we were learning about expanding binomials, one thing we learned was kind of a shortcut when you are expanding these binomials squared. And the shortcut was to take the first term and square it. To get the last term, we would take the second term, this plus 5, and square that. And then to get this middle term here, well, we would look at our first term and our second term. We'd multiply those two together and then multiply by 2. So x times 5 is 5x times 2 gives us the 10x. And so what we're going to do in today's lesson is start with this expanded form here, this x squared plus 10x plus 25, and then we're going to factor it and get it back into x plus 5 squared. So we'll look at question A here, and the way that we verify is we take a look to see first if the first and the last terms are perfect squares. So x squared is really the same thing as taking x and squaring it. 36 is the same thing as taking 6 and squaring it. And now we need to verify, does x times 6 times 2 give us that 12x that we're looking for. So because the first and last terms were perfect square trinomials, and because you take the square root of x squared and 36 and multiply them by 2, so 2 times x times 6, it gave us the middle term. That verifies that this is indeed a perfect square trinomial. So to factor it, you are just taking the square root of the first and the last. Now the sign for this is dependent on what the middle term is. So because this is a positive 12, we get the plus in the middle of the bracket. Okay, let's try that again. So in question B, we have x squared minus 8x plus 16. So let's see if this indeed is a perfect square trinomial. So the x squared, I'll just take the square root of that, which is just x. The 16 is a perfect square, same as saying 4 squared. Now, does negative 8 equal 2 times the first term's square root times the second term's square root? And indeed it does. We do get negative 8x here. So we've just verified that it is a perfect square trinomial. So to factor it, you put the first term's square root, we'll put the last term's square root, and the sign comes from the middle term. And so this time we have a minus, and so basically it is just going to be x minus 4 all squared. And if you're ever unsure, write out your answer twice because it's squared. Do your distribution, so x times x, x times negative 4, negative 4 times x again, and then finally negative 4 times negative 4. And when we collect like terms, we end up with the exact question we started with. Okay, and again, keep in mind that this is just kind of a shortcut method. If you don't realize that you're dealing with a perfect square trinomial, you can still look for two terms that multiply to 16 and add to negative 8. Okay, and then you should get x minus 4 and x minus 4. Okay, one last example. And this is where the shortcut really does come in handy, because otherwise you're going to be dealing with a very large, complex trinomial. Okay, so let's look at the first term. That happens to be a perfect square. square root of that would just be 7a. And we look at the last term. That is also a perfect square, the square root of which is just 2b. Now, does 2 times the square root of the first term times the square root of the last term, does that equal the 28ab that we're looking for? Well, 2 times 7 times 2 gives us 28, and then times a, and then times b. So it definitely is, and we've just verified that it is a perfect square trinomial. So to factor, we take the square root of the first term, the square root of the last term, and the sign comes from the middle. So I know that this will be plus. And then don't forget the little squared on the end. So that's basically how you verify that something's a perfect square trinomial, and then how to factor it. One last quick example. Okay, so in example 2 here, we want to find the values of k so that this trinomial here is a perfect square. Well, just like we've been treating the other questions, let's kind of go through the motions to kind of verify that it's a perfect square. So in the last couple of questions, we have checked that the first term is a perfect square, and we took the square root of it. So the square root of x squared is just x. We looked at the last term to see if it was a perfect square, and it is. We take the square root, and it gives us 9. And then for the middle term, to verify, that middle term had to be 2 times the square root of the first term times the square root of the last term. So essentially what we're saying is that 2 times x times 9 is going to be equal to this middle term, kx. Okay, well on the left side here, what we really have is 18x is equal to kx. And so if we're just looking for k, well then k must be equal to 18. Okay, but there is more than one possible answer here. Remember, when you take the square root, you should think of both the positive answer and the negative answer. So when you are trying to think of the square root of 81, negative 9 is also a possible answer. We can also write that the square root of the first term is x. The square root of the last term is going to be negative 9 squared. Okay, and then the middle term would be 2 times the square root of the first term times square root of the last term. Okay, so in this case, we are saying that 2 times x times negative 9 will be equal to our middle term of kx. So in this case, we actually end up with negative 18x is equal to kx. So we can say that k is equal to negative 18 in this case. So we end up with two possible answers, where k equals positive 18 or k equals negative 18. Okay, and that is it for today's lesson. If there's anything you would like to go over, please make sure you ask me in class, and I'd be happy to do so. That's it for today. Have a great night.